Hello everyone, welcome back to the series, the brand new series 10 questions to grade 9. In today's video, we are diving into one of the most powerful topic in maths, which is indices. It's very important. We'll be tackling 10 carefully selected questions that cover everything from the basic laws of indices to some challenging problems that are perfect for pushing your grade up to grade 9. Whether you're revising for GCSEs or just want to sharpen your skills, this session will definitely gonna help you and it's gonna make you more confident on it. So grab your pen and paper and stay with me till the end. So let's get started. Question 1 says simplify the following. See, before we start any question, let me explain you the rules, the laws of indices very quickly. If we know it's a to the power of m, this is indices. In this case, this is called power and this is called base number. Now, there are rules regarding with the multiplication, division and some operations with this indices. If you're multiplying two indices having the same base number but the different powers, you just need to add them up. That means only the power will get added. So it's 2 to the power of 3 times 2 to the power of 7. Clearly, this base number is same. So I'll write base number as it is and add the powers, which is 7 plus 3. So final answer will be 2 to the power of 10. Same thing if I do the division having the same base number. So a to the power m over to a to the power of n. In this case, the number will remain same. The base number will remain same. The power gets subtracted. That means 2 to the power of 7 over 2 to the power of 6 can be written as 2 to the power of 7 minus 6, which is just 2. So here we have subtracted the power. This is about, now you might be thinking, this is about when the base number is same, and what if the base number is entirely different? So the second case is when the base number is different but powers are same. So this was base number same and powers different. Here base number different and powers are same. So same, let me see how we can multiply or divide them. So a to the power of m multiplied by b to the power of m. Base numbers are different, powers are same. So I'll multiply a times b, I'll multiply base number and keep the power same. Whatever is the same, we keep that same. In this case, base number was same, so we kept base number same, and whatever the operation we did with the powers. Similarly here, the power is same, so we kept the powers as it is, only we applied the thing with the base numbers. Similarly, if it's a to the power, oh, let me just show you an example. If it's 2 to the power of 2 multiplied by 3 to the power of 2. So it will be 2 times 3 whole to the power of 2, which is 6 squared, that's 36. Now, the second one is a to the power of m over b to the power of m. So this will be divide the base numbers and keep the power same. Like 2 to the power of 4 over 4 to the power of 4. So this will be 2 over 4 to the power of 4, and 2 over 4 can be simplified as half to the power of 4, which is 1 over 16. Now the third number is what if? The base number is same and the power is also same. So in that case, there is no particular rule or law that governs it. That means you just need to solve them separately. So take the example of 2 to the power of 3 and multiplied by 3 to the power of 2. Base numbers are different, powers are different. Solve them individually, which means 2 to the power of 3 is 8 and 3 to the power of 2 is 9, and it will give you 72. That's it. That's the only way you can solve it. Now moving on to the next rule, that's called power rule. That means if there is a power over another power, that means a to the power of m whole to the power of n, which is like this one actually. This is an example of this rule. So we need to multiply the powers. So this will be a to the power of m times n, which is a to the power of mn. If there is one more power, a to the power of n, whole to the power of n, and let's say l, again you have to do the same thing. You just write the power of the base number as it is and multiply all the powers. So this will be your answer. The next is it deals with the negatives. If it's a to the power of negative m, in that case we are supposed to reciprocal it. That means this will go down there. So whatever be, like if the power is over the numerator only, not in the denominator, so only reciprocal the numerator, don't touch the denominator. So that thing will reciprocal over which there is a negative power. Let me give you an example. Because it's a to the power of negative m, it means it's a to the power of negative m over 1, sorry. So in that case, a to the power of minus m will come down. So here there will be a vacancy and only 1 will be there. Two into a to the power of negative 3. The sign, the negative power is only over m, so only a will get reciprocal. That means interchanging or swapping of numerator and denominator. Numerator will go to the denominator, that's called reciprocally. Denominator will go to the numerator, that's also called reciprocally. Since power is over a, so it gets reciprocal. Previously it was a numerator, now it will go to the denominator, and 2 will remain there as it is. And why we are reciprocating? In order to make the power positive. Similarly, if it's like this, clearly power, the negative power is entirely over 2 over 3. That means we will reciprocal 2 as well, we will reciprocal 3 as well. If suppose it's a to the power of negative 3 over 2, it's only over a, so 1 over 2 times a to the power of 3. Now moving on to the next one, which is anything to the power of 0 is always 1. So a to the power of 0 is 1. Any number 1 lakh to the power of 0, negative 32 to the power of 0, doesn't matter what number is this, to the power of 0 will always give you 1. Now these are basically few rules, and obviously there are like the fractional indices and some more thing that we will be discussing while we're doing the question, but these are the most important laws that I have already cleared you. So coming back to this question number 1, it says simplifying. This is a power rule. So obviously a 3m squared whole cube. So we have to, the most common mistake is students, they forget to cube this one. See, it's a whole power. So don't only just power this one, solve this one and keep 3 as it is. I would say 98% of my student, they does this kind of mistake. So don't do that. So you just have to cube 3 as well and this as well. So 3 to the power of 3 will be 27, and m squared to the power of 3, it's a power rule, so multiply the powers, which is 3 times 2, which is 6. 27 m to the power of 6. The next is p squared times p cubed over p to the power of 5. Okay, so p squared times p to the power of 3 whole to the power of negative 3 to the power of 5. It's actually here. This one is whole, not just on the numerator only, it's over the denominator as well. So this will be p squared minus p cubed. We'll apply the first rule, product rule, where base number is same, powers are different, you just need to add them up. So p to the power of 2 times p to the power of 3, add the powers, 2 plus 3, 5. Keep 5 as it is. And this will be to the power of negative 3. This is 1 to the power of negative 3. That means it will remain as it is. This one, a cube whole squared, applying power rule, multiply the powers. Now, this is a fractional power. Obviously, in the later stages, in the later questions, I'll explain you how to solve the fractional power. But here, only we just have to apply the same power rule, which is a to the power of m times n, which is a to the power of 6 over 2. This is 2 times a to the power of 6 over 2. And finally, it's a to the power of 6 only. Then, y squared times y cubed over y plus y to the power of negative 2 times y divided by y to the power of negative 5. Okay, this is basically to the power of negative 5. So, y squared times y cubed is y to the power of 5 over y plus y to the power of negative 2 times y. If simple y is there, it means it has a power 1. So add the powers. Negative 2 plus 1 will give you y to the power of negative 1. So it's y to the power of negative 1 over y to the power of negative 5. This one is, obviously you're dividing, having the same base number, so you just have to subtract the power. 5 minus 1 plus y to the power of minus 1 minus minus 5. You're subtracting the powers. And since these are negative powers, so you just have to keep in mind that you have to use in between the negative sign as you're subtracting. So this will be y to the power of 4 and this will be y to the power of 4. This is 2 times y to the power of 4. Question 2, simplify 8 to the power of 2 over 3 times 9 to the power of 3 over 2 over 125 to the power of 1 over 3. This is what I was talking about, fractional indices. So the few steps of doing fractional indices, I'm starting with 8 to the power of 2 over 3. These are the steps to understand or to follow. First thing is prime factorize base number. That means 8 to the power of 2 over 3 will be prime factorized at 2 times 2 times 2 to the power of 2 over 3. Second step, write base number in a to the power of m form. That means 2 times 2 times 2 can be written as 2 to the power of 3 because you're multiplying 2 3 times. And last is apply power rule. If there is a power over another power, we multiply them. So 2 to the power of 2 is nothing, just 4. So that's the answer. We can simplify 8 to the power of 2 over 3 as just 4. So this is 4. Similarly, 9 3 over 2 can be written as 9 is 3 squared and there is 3 over 2 power already there. Remaining is 3 to the power of 3, which is 27. Over 125 can be written as 5 times 5 times 5, which is 5 cubed. And 1 over 3 is up there, so it's 5. So you just need to do 4 times 27 over 5 and that will give you answer. Need not to, it all depends basically. But generally this kind of questions being asked in non-calculator, so leave your answer in fraction rather than in the decimal form, which is 108 over 5 as it is. Okay, see the next one, 27 times 125 times 216 all to the power of negative 1 over 3. Now 27, we can write them separately as well, as this is multiplication. Keep that in mind. If it's 27 plus 25 whole to the power of minus 1 over 3, 27 to the power of minus 1 over 3 plus 25 to the power of minus 1 over 3 won't work. Even I have seen when we do factorization, a plus b whole squared gets to a squared plus b squared, that's it. No, it means a plus b times a plus b, and you just have to factorize it. So don't do that kind of mistake. This is only applicable in case of multiplication, or in case of division you can separate them out. So 27 to the power of negative 1 over 3 times 125 to the power of 1 over 3 times 216 to the power of negative 1 over 3. So 27 can be written as 3 to the power of 3. Similarly, 125 can be written as 5 to the power of 3. And 216 can be written as 6 to the power of to the power of 3. Applying power rule, multiply them together, it will give you 1 over 3 times 1 over 5 times 1 over 6. And this will give you 1 over 90 as the answer. Moving on to the question number 3. Write 5 to the power of n as power of 5. 5 to the power of n over 5 to the power of n minus 3 whole squared. This is actually n, not h. It seems to be, it's n. So this will be applying it, having the same base numbers. So we just have to divide them. That means subtracting the power. But first, simplify this one. So simplifying that means this will be 5n over 5 2 times n minus 3, because we are multiplying them. That's the power rule. And then simplifying 5 to the power of n over 5 to the power of 2n minus 6. Having the base number, subtract the powers. 5 to the power of n minus 2n plus 6. Why I have changed the sign? Because I'm subtracting, obviously. So subtracting, that means this will be n minus, and this whole we are subtracting. Okay, so whatever you are subtracting, or the number after the negative sign, keep that whole inside the bracket and then expand the bracket. So you'll get n minus 2n plus 6. So this can be written as n minus 2n plus 6 is minus n plus 6. So 5 to the power of 6 minus n is the final answer, which is definitely in the form of, or in the power of 5. Now it says 8 squared times 16 to the power of 3 over 2 over 256 is equals to 2 to the power of n minus 1. Find the value of n. For such type of questions, whatever is on right hand side, you have to convert, because on right hand side it has a base number 2. So try to convert every number or whole of this in terms of 2 to the power of something, so that at the very end we can compare the power and get the value of n. See, let me show you how. Because on right hand side it's 2, so I'll try everything in the power of 2. So 8 squared, either I can directly simplify here or convert them into 2c. Like 8 squared is 64 times 16 to the power of 3 over 2, and this is 256. We know that 256 is 16 times 16. So 64 over 16 times 16 times 16 to the power of 3 over 2. We know 16 4s are 64, right? And 4 times 4 is 16. So this can be written as 16 to the power of 3 over 2 over 4. Now see, 16 to the power of 3 over 2, I told you to solve fractional indices, you have to convert the base number in the form of e to the power of m. And we know it's 2 to the power of 4. So 2 to the power of 4 times 3 over 2 over 4, which is 2 to the power of 6 over 4, or 2 to the power of 6 and 4 can be written as 2 squared. Having the base number, if you're dividing, subtract the powers, this will be 2 to the power of 4. This whole will be simplified into 2 to the power of 4. So 2 to the power of 4, in place of this I can write 2 to the power of 4 is equals to 2 to the power of n minus 1. They have the same base number, only compare the powers. So 4 is equals to n minus 1, And finally, n is equals to 5. And that's your answer. Now it says, find the LCM of these three numbers. LCM of these three numbers, that means we have to use the same method how we find the LCM of any particular number. That means that method where we'll be writing 55 to the power of 21, 55 to the power of 27, 55 to the power of 31. I'll take out this number that is common among all, which is 5 to the power of 21. That I can divide with everyone. So 5 to the power 21 divided by 5 to the power 21 is 1. Or simply you can see that one which the maximum number that you can take out as common. This will be subtracting the powers. 27 minus 21 will give you 55 to the power of 6. And this will be 55 to the power of 10. Again, among these, like between these two, I can take out 55 to the power of 6 as common. So 1 will remain as it is. This will become 1 and this will become 55 to the power of 4. Now, there's nothing else. Only 1 remaining there. There's nothing common in between any. It has to be common among 3, 4, even 2. But if there's nothing common even within 2 numbers, end it there. This is a simple LCM method that we always use, that I'm using. Multiply these whole numbers. So these are 5 to the power of, this is 55. 55 to the power of 21 times 55 to the power of 6 times 55 to the power of 4, which is 55 to the power of 31. And that's your answer. Simplify the following expressions. 10a to the power of negative 3b to the power of 4 times 25a to the power of 4b negative 3 over 30a cubed b to the power of 4. See, you have to apply the operations with constants and variables and variables. That means 10 is multiplied with 25 divided by 30. I'm just separating out the constants and numbers. For a, we are multiplying a to the power of negative 3 and 4. That means I need to add them up. So 4 minus 3, a to the power of 1 divided by a to the power of 3 times b to the power of 4 times b to the power of minus 3. That means I need to add them up. This will give me just b over. This is b to the power of 4. This can be simplified as 25 over 3. This is because having the same base number but different powers, we are just dividing. So subtract the powers. So a to the power of 1 minus 3. Similarly, a to the power of 1 minus 4. So final answer is 25 over 3, a to the power of negative 2, b to the power of negative 3. Or I can write 25 over 3a squared b cubed. And that's your final answer. Part B says 1 over n times n to the power of 3 over 2, and we have to write it in the form of n to the power of k. So obviously in denominator we can clearly see there are two indices having the same base number, different powers gets multiplied, which means keep n as it is. This means it's 1. So I just need to add the powers. So this can be written as 1 over n to the power of 5 over 2. Now, some of you might be thinking why 1 plus 3 over 2 is 5 over 2. So 1 plus 3 over 2, 1 is 1 over 1. And what's the LCM of 1 and 1? 2. So multiply 1 and 2 is 2. So 1 times 2 and here 2. To make the denominator, I'll multiply and divide with the same number. 2 plus 3 over 2 will give you 5 over 2. And finally, because they're asking you to express an n to the power of k and should be numerator, and that could be done only if I reciprocal it and make it negative. If n to the a to the power of negative 1 is 1 over a, so 1 over a can be written as a to the power of negative 1. And that's how you have expressed it in the form of a to the n to the power of k. Question number 5. It says evaluate 27 to the power of 2 over 3 over 125, and they both have the same common power. So 27 over 125 to the power of negative 2 over 3. So we have to convert both into the form of a to the power of m. 27 is 3 times 3 times 3, which is 3 to the power of 3. Similarly, 125 is 5 times 5 times 5, which is 5 to the power of 3, whole to the power of negative 2 over 3. Which means I can write 3 to the power of 3 times negative 2 over 3. 5 to the power of 3 times negative 2 over 3. So it's 3 to the power of negative 2 over 5 to the power of negative 2. Which is, we have to first reciprocal. So it will go down there and will become positive. And 5 will go up there, becomes positive. And final answer is 25 over 9. Part B, it's 5 to the power of 3 divided by 5 to the power of negative 7 plus 5 to the power of 5 times 5 to the power of 5. Same base number, powers are different. We are dividing, subtract the powers. 5 to the power of 3 minus 7 plus same base number, multiplying, add the powers. 5 plus 5. So 3 plus 7 is 10, so 5 to the power of 10, and 5 plus 5 is also 5 to the power of 10. Final answer is 2 times 5 to the power of 10. So basically, we have done question till question number 5. The rest of the question from question number 6 to question number 10 we'll be doing in part 2. These are total 10 questions that are more than enough to give you to upscale your grade, as well as to give you an enough idea for indices even you are new to this concept. So that's it for today, and we'll be back from question number 6 in part B. Take care. Bye.